We're on lesson 83 today, which is about probability and independent events with replacement and without replacement. So what I'd like you to do before you go further in the videos, I'd like you to read page 499 so that you understand what basic probability is about. Basic probability is the total number of outcomes that you want to have happen divided by the total number of possible outcomes. That's just simple probability. So if you turn to page 500, you did this back in Algebra 2, and I actually think it was taught in Algebra 1 as well. So it should be like riding a bicycle. It'll come back to you after you see it. It says 2 fair dice are rolled. Whenever you see that kind of a problem where you have 2 fair dice involved, the first thing you're going to do is make the chart of all the possible outcomes. So you have one die that has 1, 2, 3, 4, 5, 6, and another die that has 1, 2, 3, 4, 5, 6. And it's like playing on the craps table. I've never played on a craps table, but I know that that's how this operates. It doesn't matter what the individual die are themselves. It's the sum of the 2 die that are rolled that matters. So this is just a simple addition chart. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 5, 6, 7. Same thing happens here. 3, 4, 5, 6, 7. 2 and 3 would be, 2 and 2 is 4, 5, 6, 7, 8. 5, 6, 7, 8, 6, 7, 8, 9, 7, 8, 9, 10, 8, 9, 10, 11, 9, 10, 11, 12. And you'll know you did it right if you end up with a 12, because if you get double sixes, the most that you can get is a 12. Now once you do that, you cross this out, because we don't count those anymore. They don't mean anything to us. Only these numbers right here. And by the way, how many numbers are there right here? There's 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So 6 times 6 gives us a total of 36 outcomes in that table. Now we can go back to the problem. Part A says, what is the probability of getting a 7? So you count the 7s. 1, 2, 3, 4, 5, 6. Out of how many total possibilities are there? 36. So that reduces to 1/6. So the probability of rolling 2 fair die and getting a 7 is 1 out of 6. And the reason they say 2 fair die, do you think there's such a thing as an unfair die? Yes, there is. If you go to Las Vegas, for example, it's very possible that one of the dice is weighted heavily on one side, or even just a little bit more heavy on one side. It'll have a tendency to land on that side. And they could do something like just simply put a dot of clear nail polish on one of the numbers, and that'll make it just heavy enough that it'll tend to fall on that side instead of be fairly distributed between the 6 numbers. So yes, there is such a thing as an unfair die. All right, letter B says, what is the probability of getting a number greater than 8? So greater than 8 does not include 8. So I'm going to cover up everything 8 and below. That'll give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of how many total? 36, and make sure you reduce it. So it'll be 5 out of 18. All right, remember, if it says greater, it doesn't include that number. If it said greater than or equal to, then we would have included the 8s, but it didn't. So that's how we get that. All right, next, let's talk about coins. We're only going to deal with fair coins, so they're not weighted on either side. So we have a 50-50 shot of getting a head or a tail. The probability of getting a head would be 1 out of, there are 2 faces of the coin, so it'd be 1 out of 2. The probability of getting a tail would be 1 out of 2. Now, let me give you an example of something. If, because we're all rather bored right now and don't have anything to do, except now you'll have your homework to do. You just take a coin and just flip the coin and keep track of how many times that you get heads and how many times you get tails. If you do the experiment enough, you should end up with the same number of heads as you get tails, or very close to the same, because we do have an equal opportunity to get a tail or a head. The thing is if I flip that coin 20 times and it came up heads 20 times, what's the probability that it's going to come up heads on the next toss? It's 1/2, isn't it? Because it doesn't matter how many times I've flipped this coin and gotten a head. It doesn't have anything to do with what's about to happen in the next toss. So what already happened doesn't change the probability of anything. All right, so on page 501, this says a fair coin is tossed 3 times. What is the probability that it comes up heads every time? Well, what's the probability it comes up heads the first time? 1 out of 2. And if it wants us to do this 3 times, we have to multiply these probabilities. So what's the probability that it's going to come up heads the next time? It's 1 out of 2. And again, multiply, because we got 3 tosses here. What's the probability it'll come up heads the next time? 1 out of 2. So the probability that all 3 of them will be heads will be 1 times 1 times 1 over 2 times 2 is 4 times 2 is 8. So the probability would be 1/8 that all 3 of them would be heads. All right, next. A fair coin is tossed 4 times and it comes up heads each time. What is the probability it will come up heads on the next toss? Think about what I just told you about. What already happened is not going to change the probability of what's going to happen in the future. So the probability it comes up heads on the next toss is still 1/2. Okay, next, we're talking about an urn. It's kind of like a flower vase. Urns that we think of are maybe when someone is cremated and their ashes are put in an urn. Well, most of them look similar to what a flower vase would be without a lid. So just think about putting these marbles inside of a vase. So it says an urn contains 2 black marbles. So 2 black marbles, 2 white marbles. A marble is drawn at random and replaced. So that means we pull it out, but then we put it back in after we look at it. Then a second marble is randomly drawn. So A, what is the probability that both marbles are black? Well, we have 2 black marbles out of a total of how many marbles? 4. So the first time it says, what is the probability that both marbles are black? All right, and it said the first one was replaced. All right, so we had 2 black marbles out of a total of 4. Okay, then we're going to put that marble back in the bag. And it wants to know what's the probability of getting a black on the next one. Well, if we pull the black one out, we pull it out, but then we put it back in, we still have 2 black marbles out of a total of 4 marbles, correct? So this would be 1/2 times 1/2, which is 1/4. All right, the next one, letter B, says, if the first marble is not replaced before the second marble is drawn, what is the probability that both marbles are black? All right, so the first condition is still the same. Before we draw anything, we have 2 black and we have 2 whites. So the probability of getting a black on the first one is still 2 out of 4, isn't it? But this time, we pull a black marble out. So now, and we're going to leave it out. We're not going to put it back in. So how many black marbles do we have remaining in the urn? only 1, because we pulled that 1 out. And it's not 4 marbles in there anymore, because we pulled that one out and didn't put it back in. So now we have 1 of these and 2 of these, which is a total of 3. So I can reduce that to 1/2 and multiply straight across. 1 times 1 is 1, over 2 times 3 is 6. So if we pull the first marble out and don't put it back in, then the probability that both of them are black is only 1/6. So it's a little less than this one was. Okay, last thing we talk about is a deck of cards. A 52 deck of cards. So we have 13 spades. For those of you guys that have never played with a deck of cards, 13 clubs. Both of these are black cards. Then we have 13 hearts and 13 diamonds. And both of these are red. So half of the deck is red. Half of the deck is red. Half of the deck is black. Okay? There's 4 suits, spades, clubs, hearts, and diamonds. So the 52 divided by 4, each one of them has 13. All right, so it says 2 cards are drawn from a 52 card deck without replacement. So we pull that card out, we leave it out. We don't put it back in. What is the probability that the first one is red? Well, how many are red? 13 and 13, 26 out of a total of 52 cards. Okay, so there's the probability the first one is red, and the second one is black. Okay, so the first time we pulled out a red card, didn't we? Okay, we pulled out a red card, but it's asking the probability of getting a black one the next time. So how many blacks do we have left? We still have 26 blacks. But we pulled out a red card. So instead of having a total of 52 cards, we only have how many left? There's only 51. Okay, now reduce that. This is 1 over 2. And then 2 will go into 26, 13. So it'd be 13 over 51. Always put your probabilities in simplest form. Don't ever leave a fraction that can be reduced. And that's all there is to simple probability and with replacement or without replacement. All right, so make sure that you have this uploaded by Thursday at the time of your class. And let me hear from you. If you have questions, either call me or email me. And I will see you tomorrow for